There are many different ways to group elements on the periodic table and many different trends in the periodic table. Today we will go over just a few. First, we will go over different ways to group elements on the periodic table and groups and periods. One of the most basic groupings is into metal, nonmetals, and metalloids. The blue ones are metals. The greens are nonmetals. And the orange are metalloids. Metals are solid at room temperature, are good conductors of heat and electricity, and are malleable. Nonmetals can be solids, liquids, or gases at room temperature. They are poor conductors of heat and electricity, and unlike metals, they aren't malleable or ductile. Metalloids are elements that have properties of both metals and nonmetals. They aren't ductile or malleable. Metalloids don't conduct electricity as well as metals do, but they are better conductors than nonmetals. As you can see, the metalloids form the border between the metals and the nonmetals on the periodic table. The vertical columns on the periodic table are called groups. The elements in a group all have the same number of valence electrons and have similar properties. Some named groups are Group 1 and Group 18. The elements in Group 1, excluding hydrogen, are called alkyl metals. These elements all share properties such as high reactivity, soft texture, and low and boiling and melting points. The elements in Group 18 are called noble gases. These elements all share properties such as being odorless, colorless, non-flammable, and having low chemical reactivity. The horizontal rows on the periodic table are called periods, and each next element has one more proton than the previous element. Now we will go over some different trends on the periodic table. First, we will look at reactivity in metal elements. Metal atoms with the fewest valence electrons lose them the most easily. Large atoms can also lose electrons more easily because their valence electrons are farther from the nucleus. For these reasons, metal elements near the bottom and left of the periodic table are the most reactive. This periodic trend of reactivity explains why the alkyl metals are so reactive. Next, we will look at trends in atomic radii. Atomic radius is an approximate measure of the distance from an atom's center to its edge. Because an atom's electron cloud doesn't have a distinct edge, different methods of measuring an atom's radius produce slightly different results. The atomic radii of the elements increase as we move right across the periodic table. The increase is due to the decreasing number of protons. This is because the nucleus of atoms with more protons have stronger positive charges, which pulls electrons in more closely, decreasing the radius. The atomic radii also increase as we move down. This is because elements lower on the table have more energy levels, so their valence electrons are farther from the nucleus, giving the atom a larger radius. Atoms that have lost or gained electrons are called ions. An ionic radius is a measure of the distance from the center of an ion to its edge. When atoms lose electrons to become positively charged cations, their radius decreases. When atoms gain electrons to become positively charged anions, their radius increases. The trend in ionic radii in the periodic table is the same as that for atomic radii. The largest ions are found in the bottom left corner of the table, and the smallest ions are found in the top right corner. However, the trend applies differently for metals and nonmetals. Look in period 3, the ionic radii decrease as we move from sodium to silicon. The next element is phosphorus, a nonmetal. Its ion is larger than silicon, but the trend of decreasing size remains for the three nonmetal ions in the same period: sulfur, chlorine, and argon. Ionization energy is the amount of energy required to remove a valence electron from an atom. In small atoms, the valence electrons are close to the nucleus and strongly attached to it, so it takes more energy to remove them. Therefore, ionization energy for small atoms is greater than that for large atoms. Additionally, elements that easily react to form positive ions are the ones with the least ionization energy. Reactivity increases towards the bottom left of the periodic table. So, ionization energy is lowest towards the bottom left of the periodic table. it increases towards the top right of the table. This means the trend is increasing ionization energy as we move up and to the left. The trend is the same for electronegativity. Electron negativity is a measure of how strongly the atoms of an element attract their valence electrons. It applies to an atom that's in a chemical bond with another atom. The electrons of large atoms are farther away from the nucleus than the electrons of smaller atoms. As a result, the attraction of valence electrons in large atoms is weaker than the attraction in smaller atoms. So, the larger atoms lower down in a group are less electronegative than the smaller atoms higher in a group. Across a period, electronegativity increases from left to right.